Hello everyone, what's happening? My voice is better, I promise. Hey Robin. Robin was early. Robin Cook. Give it time for people to join. If you do join though, let me know. If you're chilling, just let me know you're here. Then we'll get started real soon. Hey Apasna, how's it going? How's your holidays going? Let me know if you can hear me alright as well. Guys, as you enter, just let me know who's there. I'm seeing the viewership going up. Hey Boomy, how's it going? How's your holidays going? Hey Sarah. Hopefully you guys are doing all the revision you need to be doing. Hey Sadia. Let me know what year groups you lot are in as well. Hey Bella. What year groups you lot coming from? 12? Ah, year 12s. Nice. Ah, you're all year 12. This is very good for you then. Um, what was I going to say? Make sure you guys are subscribed because I'm going to be making a lot of year 12 videos. All these free streams are going to be covering a lot of that stuff. Sadia's in year 13, so this will be revision. But a lot of this, so Sarah's in year 12 as well. Make sure you guys are subbed because I'm going to be doing loads of these. Yeah, so you want to make sure you're up to date with everything I do. It'll be great revision for you. And then I'll tell you a bit more about what I'm doing outside of the YouTube stuff as well a little bit later on. If you guys could hit the like button as well, it'll help me out a lot. I appreciate it. I appreciate you guys coming out on a Thursday 2 o'clock. Maybe you guys have just had your lunch. I just had my lunch. I had a Tesco meal deal, which is the usual for me. Although Tesco have increased their prices, which is a bit mad. It's gone up to £3.40, which is craziness. It's gone from £3 to £3.40. So, you know, hitting the pockets a little bit. I think I'll give it 1 minute and then I'm gonna make a start. But yeah, guys, as you enter, just let me know you're here. Maybe let me know what year group you're in. Make sure you're subscribed so you can get more content like this, more of my streams. I'm going to be uploading a YouTube series as well. If you haven't seen it already, I uploaded one on Tuesday on A-level quadratics, and it's going to be a common theme. So I'm going to be covering through a lot of the year 12 content, which will be great revision if you're in year 13. So yeah, the best way to make sure you stay up to date with that is if you're subscribed, obviously. I'm uploading another video on that today, actually. So make sure you lot stay tuned for that. All right, I think we can make a start. I'm seeing a few more people joining, which is great. As you enter, guys, just let me know who's there. Remember, the whole point of these streams is to be interactive with each other, discuss the maths, discuss all things life, potentially. But yeah, mainly just have fun, learn at the same time. Yeah? All right, cool. I mean, I'm seeing a lot of new faces from last week. Last week we covered some still trigonometry. If you missed that, you can go back to my videos and rewatch it. But we're building on that knowledge. But because loads of you are new, I'm just going to give you a quick update as to who I am, because it's a lot of you I've spoken to on WhatsApp and stuff. But just a quick summary. I'm just going to go big for a second to fill up this space. What's up, you lot? All right, so who am I? Meet your teacher. So one thing about me, you lot can see my name from my YouTube channel, but I'm a fully qualified teacher with several years of experience. I've been the previous head of A-level maths at multiple successful schools in Northwest London. I've got my first class honours in maths from UCL. My geekiness in maths did start when I was your age. So if you're in year 12, I would say my true geekiness started in year 12. We used to have January exams, but they've scrapped that. But January exams was kind of a wake-up call for me. And that's when my geekiness kicked in. I did get my 2 A stars in maths and further maths. I did sit my normal maths A level 1 year early when I was 16 years old. And yeah, I still got the A star, which is great. I also did something called the Advanced Extension Award. It's not really sat that much these days, but it is something that is still sat. Now, usually what the Advanced Extension Award is used for is it's an exam sat by the top mathematicians in the country, and is graded by distinction, merit, and then fail. So if you get a distinction, you're regarded as one of the top mathematicians in the country. In fact, you'd be regarded as between like the 1 and 2, top 2% of all the mathematicians in the country. And I did get that distinction. I was 17 years old when I did that. So yeah, after I did my maths degree, I went on to become a teacher because all great mathematicians go on to do teaching. So for me, it's teaching, gym, all that kind of stuff. So if you want to know more about that, then for sure you should check out my social medias, which I'll post at the end. So yeah, more information on that is there. I'm also an EdXL examiner, so I do mark papers, and I still mark papers. So you never know, maybe I mean, your names will be hidden, but you never know. Maybe I'll be marking one of your lots' papers next year. Hey, Wace, nice to have you here. But yeah, because loads of you are in year 12, maybe I'll end up marking your papers next year. You never know. But like I said, I won't end up seeing your name, so you lot can't slip me £10 and ask me to be lenient with you. Yeah. Ah, hey Ibrahim. I'll try and remember. Yeah. But yeah, like I said, guys, if you want more content like this, like today we're doing trigonometry. Next week I'm moving on to differentiation. So if you want more of that and you want to attend, then make sure you're subscribed and please hit the like button because yeah, like I said, it helps me out a lot, yeah, in terms of creating content and trying to push it to a larger audience. I'm uploading a YouTube series of content mostly covering year 12. And yeah, next week I'm starting differentiation as well. So make sure you lot attend the stream for that. Yeah. Right now, you can see in the top corner there, I'm working at a company called MES where I'm developing the maths curriculum. But more on that later on. I'll describe to you a bit more about what I'm doing there. So it's a bit more about what this this kind of style of teaching, live streams, then homeworks online, that kind of stuff. More interactive, more fun. We're trying to create a community of mathematicians that want to do well. Yeah. Ibrahim, you've never met a teacher who's got an A-star in maths, no? I'm the first one. I appreciate it. All right, let's start on the theme of today. Now, as you can see from the title says "Man like Pythagoras." If you don't know already, I'm from London, so we have like London slang, but really it's UK slang, right? This is the way we speak. But in trigonometry, we do use Pythagoras' theorem, and I'm going to show you how we apply it to trig. So if you have any questions, always put in the chat straight away. Yeah? Going small again. I hope we're all ready. So we're going to deal with equations where we have a mixture of sin x and cos x, including squared functions. Here we will use our Pythagorean identity derived in our first lesson. So this is technically the third stream I've done. So if you want to go and revise what I did in the first lesson, please go and do that. But what I did in the first lesson is I proved the identity sine squared x plus cos squared x equals 1. Yeah, so hopefully if you haven't attended that lecture, you've hopefully seen this already, maybe in school. But this is an identity, it's a fact. If you square sine x and you square cos x and you add them together, that equals 1. Yeah? And go back to my first lecture on this where I prove it to you. It's a really interesting proof. It just comes from circles. Yeah? So, part A of a question says, show that the equation 5 sine x equals 1 plus 2 cos squared x can be written in the form 2 sine squared x plus 5 sine x minus 3 equals 0. Okay, whenever we solve trig, we want to make sure that all the functions are the same. So you can see in this equation, there's a mixture of sine and cos, right? Whenever we solve, we either want everything to be sine or we want everything to be cosine. Then you have to think, what is easiest to convert? Is it easier to convert that sine x into a cos x, or is it easier to convert the cos squared x into a sine x? Now, the way you decide is always look at the term which is not squared. Because sine x is not squared, you want to convert everything to sine. Because to convert sine to cos, it's like, how do you do that? Yeah, there's nothing that relates explicitly sine and cos, unless you introduce tan, but we don't want to introduce tan. So we need to change cos squared x. How do we change cos squared x into sine squared x? Well, we use the identity I've just written at the top, which I proved in my first lecture. So we write that down. Okay, we know sine squared x plus cos squared x is 1. I want to rewrite this so that it's rearranged for cos squared x, and then I can rearrange it for sine. So the way we rearrange for cos squared is the sine squared x is going to move to the other side. When it moves to the other side, it's going to be a negative sine squared. So we get cos squared x equals 1 minus sine squared x. Now I want you guys to basically remember that. So cos squared is 1 minus sine squared. Also, sine squared is 1 minus cos squared. Yeah? So it's easier to remember than writing those two lines every single time. So we're going to take that 1 minus sine squared and substitute it into this. Yeah? Okay, so we're left with 5 sine x equals 1 plus 2, and then cos squared x is 1 minus sine squared x. Now we have everything in terms of sine, we can go ahead and expand and bring everything to one side. So expand the brackets, we have 5 sine x equals 1 plus 2 times 1, 2. 2 times minus sine squared x is minus 2 sine squared x. And then we're going to move everything to one side. You have a negative sine squared. We always want to make sure that's positive. So move that to the left side. So minus 2 sine squared x, when you move it to the left side, will become positive 2 sine squared x. Then we got plus 5 sine x. Then 1 plus 2 is 3. Move it to the other side, will be minus 3 equals 0. And you can see that shown now. That's what we wanted, right? This is always the common theme with exam questions. They make you show a trig equation just in case someone couldn't do it. Now you have the answer, we can use it in part B. It says, solve for x being between 0 and 360, 2 sine squared x plus 5 sine x minus 3 is 0. So the question is, how do we solve this quadratic? Because it is a quadratic, you can see that there is a sine squared, a sine, and a number. The way we can see it's easily a quadratic is we can let u equal sine x. Yeah, something we commonly do at the beginning of year 12 where we have the hidden quadratic stuff. We do in exponentials and logarithms as well. So if u equals sine x, then sine squared x will be u squared. Then we have 5 sine x is u minus 3 equals 0. Then we solve the quadratic. 2 brackets. Now remember, you guys have the A-level calculator, I'm sure. Don't be tempted to, well, this is what I'll do actually. If you lot are lazy, check this out. I mean, you guys have probably seen this before. When I say that, I mean you lot have seen a calculator before, but what you could do is, you go on menu, then you press the button for A, you solve the polynomial. You go 2, 5, minus 3. You find out your solutions, so we have a half and minus 3. So you have a half and minus 3. You can write that down. So u equals a half and u equals minus 3. But from there, make sure you go back and say what the factorizing must have been. So if u was minus 3, for example, the bracket must have been u plus 3. It's like factor theorem, right? If u was a half, you basically rearrange. So you times by 2, so it'll be 2u. Then you subtract 1. You basically rearrange it back for 0. Yeah, so like minus 3, when you add it over, it becomes u plus 3. So here all I did was I did u times 2, which is 2u. Then you minus the 1 over. Yeah? But remember, we weren't solving u equals 1/2, right? We were solving sine x. U was sine x, so we're going to do sine x equals 1/2. And sine x is minus 3. Right, before I solve this, guys, the sine x graph, picture in your head, what y values does the sine graph lie between? Between what and what? What on the top and what on the bottom? What values does the sine graph lie between? Because we know it's a wave, right? But what does the sine graph lie between? Which y values? So meaning the sine graph goes up to what value at the top of its peak, and then what value does it go to the bottom of its peak? Good, Boomy? 1 and minus 1, yeah? Now, because you know the sine graph goes between 1 and minus 1, you immediately know that sine x cannot equal minus 3 because the sine graph can only go down to minus 1, right? But what you could do in your calculator is you do inverse sine of minus 3 and then it'll just say maths error. Now, solving sine x equals a half. The first thing we do is we do inverse sine of 1/2. Yeah. Now, you guys may have missed this if you weren't here in my first stream, but it was probably the most important stream because I show you how to solve any sine, cos, arm radians. If you're in year 12, you don't know what radians are yet, but you'll learn them in year 13. But we got 30 degrees, yeah? So we got 30 degrees. Now, just to re-explain what we did in the first lecture, is that when you do inverse sine of any number, or inverse cos or inverse tan of any number, the number it gives you in the calculator is known as the primary value, or the PV. Now, after this stage is where so many students do loads of different methods. They use something called the cast diagram, which is the most awful method I've ever seen. Obviously, the most awful, well, what is that random message? That's random. Is that a bot? Sorry about that, guys. Let me try and get rid of that. Okay, so apologies. When you do inverse sine, inverse cos, or inverse tan, then we call that the primary value. Now, it's really important that you do go back to my first lecture on this, is to work out what we call the secondary value is for sine, you do 180, take away the primary value. And it doesn't matter what you're dealing with, yeah, even if the primary value is negative or whatever, you always do 180 minus. Now for cosine, what do? You do 360 minus. What do you do for tan? You do 180 plus. I'm going to do a little summary for you guys at the end, but please do not use, I mean, it's your choice, right? You can use the cast diagram and all that stuff, but the cast diagram really is, you know, when we mark papers, we don't look at the cast diagram. It doesn't interest us. And also drawing the graphs. You don't want to draw the graphs because it's just extra effort. So for sine, you always do 180 minus the primary value, which 180 minus 30 is 150, which is your secondary value. And now you can see both of these values are between 0 and 360. So they are our only two values. Yeah? Hey, Amit, how's it going? When you say got, are you talking about Game of Thrones or are you saying you got the right answer? What do you mean by got? Or maybe means something else, I don't know. But reminder, for sine, you do 180 minus the primary value. For cosine, you do 360 minus the primary value. And for tan, you do 180 plus the primary value. And it never changes. Yeah? Oh, you got the answer. Well done. Okay. Now the last step, which we usually do, depending on the range is between 0 and 360, is that we add or minus 360 because the sine and cosine graphs, they cycle every 360 degrees. I've got a nice infographic at the end. You guys can screenshot it, yeah, once I have it on. But let's try another question. It says solve for x being between 0 and 360, 3 sine squared x plus 7 sine x equals cos squared x minus 4. So the first thing we have to do is we have to decide if we're going to rearrange or convert everything into sine or cos. What do you guys think? Are we going to convert everything into sine, or are we going to convert everything into cos? Convert everything to sine or cos? Okay, so Amit says cos. Now, if you do try and do cos, you can convert sine squared, yeah, using 1 minus cos squared. The only problem is converting sine x into cos. So converting sine x into cos is not possible in normal trigonometry, yeah? So remember this, always look at the term that is not squared. So because sine x is not squared, you want to convert everything into sine, yeah? I mean, let me know if that makes sense, yeah? So because sine x is not squared, we can't convert it, so we want to convert everything into sine here, yeah? So going along, we have 3 sine squared x plus 7 sine x. Then remember what we said in the last slide, cos is 1 minus sine squared. Then we have 1 minus, and then we just have the minus 4, yeah? Now, moving everything to one side, so we want to move everything to the 3 sine squared side. So the minus sine squared, when we move it over, it'll become the plus sine squared. Then we have 1 minus 4. Yeah, 1 minus 4 is minus 3. So when we move it to the other side, it'll become plus 3. So you have 3 sine squared x plus sine squared x is 4 sine squared x. Then we have plus 7 sine x. Then we have plus 3 at the end. Now we have to solve the quadratic. Yeah, so we're going to let u equal sine x. So we get 4u squared plus 7u plus 3 equals 0. Now from here, you can use your calculator. So we can go just menu A polynomial. Now we've got 4, 7 minus, plus 3. Okay, so you have minus 3/4 and minus 1. Minus 3/4 and minus 1. So what u is minus 3/4 and minus 1. Now remember, don't just write that down. Use that to factorize. So move the minus 1 over. So you get u plus 1. Then you times by 4, so it'll be 4u. Then the minus 3, when you bring it over, will be plus 3. Now don't forget what we were doing. We were solving sine x equals minus 3 over 4. And sine x is minus 1. Now, just for ease, I'm going to do the sine x is minus 1 first. So in the calculator, we're going to do inverse sine of minus 1. So inverse sine of minus 1. That's minus 90 degrees. Now remember what we said. The first value you get, we call the primary value. Now we want to work out the secondary value. To work out the secondary value for sine, no matter what's going on, is you do 180 take away the primary value. Yeah? So when you do 180 take away the primary value, remember the primary value is minus 90. I'm just going to write answer. You get 270. So you get 270. Now we call that the secondary value. Now you notice that the range is between 0 and 360, right? So this is in the range, but that is not in the range. So once you notice that some values are not in the range, you want to think about adding or minus 360 because the graphs cycle every 360 degrees. Now if you take minus 90, If you want to find an equivalent value that's in the range between 0 and 360, we're obviously going to add 360 to it. But what you notice is if you do minus 90 plus 360, you also get 270. So the only solution for that one is 270. Yeah, for sine x is minus 1, the only value between 0 and 360 is 270. Now let's do the same with sine x is minus 3 over 4. So we do inverse sine of minus 3 over 4, which is minus 48.59 dot dot dot. I'm just going to do one decimal place. Minus 48.6. That's our primary value. Then we do 180 minus the primary value to get the secondary value. So we're doing 180 minus the primary value, which is 228.6. 228.6. And that's our secondary value. But you also notice that the primary value is not in the range, right? So what we do is we take our primary value, and then to find another value in the range, we add 360. So minus 48.6 plus 360 gives us 311.4, and that is in the range. Yeah, so our overall values are x equals, we had 270 at the beginning, then we worked out the 228.6, and we worked out the 311.4. A question like this on its own could be 8 marks. Yeah, in year 12, it could be 8 marks. So a very, very important question. Yeah, remember, let me know, guys, if you have any questions. Right, next one. And the shading has gone a bit weird here, but it's 2 questions. This was a past exam question and it was worth a lot of marks. I think overall this question it went up to like 12, 13 marks for both parts. Yeah, so it's obviously a question that we just can't get wrong. Yeah, 12 to 15 marks in one paper is crazy high. Yeah, so let's see how we address it. Solve for x being between minus 180 and 180, tan of x minus 40 equals 1.5. Give your answers to one decimal place. So we're solving tan x minus 40 is 1.5. Now this relates to my previous lecture, the one I did last week. The range is for x, but our angle is x minus 40. So what we need to do is we need to do something known as modifying the range to then make sure that this original range reads x minus 40. Yeah, so we need to modify the range, yeah, by subtracting 40 from every single value. 180 minus 40 is minus 220. Then we get x minus 40. Then 180 minus 40 is 140. So now the angles are the same. We can now do all the same rules. Guys, do you remember what I told you earlier about how to work out the secondary value for tan? Do you guys remember what I said? For sine, it was 180 minus the primary value. For cosine, it was 360 minus the primary value. Do you guys remember what it was for tan? Put in the comments if you think you remember. You can use PV instead of saying primary value, but do you guys remember how to do it? So I'm doing inverse tan of 1.5 now. But if you guys remember how to work out the secondary value for tan, let me know. So we got 56.3 is our primary value for tan. Does anyone remember how to work out the secondary value for tan? Hey Robin. Good pasta. It is 180 plus the primary. Yeah? So we are doing, once we have the primary value for tan, you always do 180 plus the primary value to get the secondary value for tan, yeah? So 180 plus that answer is 236.3. And that's our secondary value. Now remember, good Sarah, 180 plus the primary. You notice we must look at the modified range. So the 56 is in the modified range, but this is not in the modified range. So step 2 is once we have our primary and secondary values, is we add or minus 360. Now, to the primary value, we are obviously not going to add 360 because that's going to become way bigger than the 140. We're actually not going to subtract 360 either, because if you do 56 minus 360, that's going to be in the minus 300. So it's too small. Our limit there is minus 220. So the only one we might need to check is this 236. We're obviously not going to add 360 to it, right? But we might be able to minus 360 to it. And make sure you don't do it the other way around. A lot of students, they do 360 minus. You have to take the value and minus 360. Now it's on my screen. I'm going to subtract 360 from that value. And there we go. That is a value inside the modified range. We get minus 123.7, I'll say, when you round it. Now, don't forget these values here. So this one is in the range. The ones I've ticked, they are for x minus 40. So therefore, x is, we have to add 40 to both of those values. So minus 56.3, if we add 40, we get 96.3. And minus 123.7, that's in my calculator. I'm just going to add 40 to it. I get minus 83.7. And these are your two values. Yeah, this would be a nice 5-mark question in the exam. All right, next one, part 2. I'll do this in a different color. Solve for theta being between 0 and 360, sine theta tan theta equals 3 cos theta plus 2, showing each stage of your working. Now, this is an interesting question whereby there's no squares in them, but there is tan. Now, a few of you guys, I think everyone here is pretty much new, I would say. Do you guys know what tan theta is equal to? What is tan theta equal to? Or tan x? Have you guys learned trig yet? Do you remember what the identity is for tan? It's a division. Do you remember what tan is the same as? And I do prove it in my first stream, which you guys can go back and check out. 2 weeks ago I did it. Time's going quick. Good, Vipassana. Sine over cos, yeah? So it says sine theta, we convert everything into sine and cos. So tan is sine theta over cos theta. Then we have equals 3 cos theta plus 2. Now we simplify, so sine times sine is sine squared theta over cos theta equals 3 cos theta plus 2. Now next step is we need to get rid of denominators, so we need to times everything by cos theta. Yes, this denominator goes. So we have sine squared theta equals 3 cos squared theta plus 2 cos theta. Now, next question is, do we want to convert all of that into sine, or do we want to convert everything to cos? What do you guys think? Are we going to convert everything to sine, or are we going to convert everything to cosine? See if you remember my ideas of how you should convert stuff. Good, Sarah. We want to convert everything to cos, right? Because you look at the term which is not squared, which is cos, because it says 2 cos theta. So we convert everything into cosine, yeah? But I'm going to change color. I'm going to move slightly to the right. So that sine squared, we have to convert it, and we know sine squared is 1 minus cos squared. Then we get equals 3 cos squared theta plus 2 cos theta. Now we move everything over to the right side. So minus cos squared, we're going to add it over to 3 cos squared, which makes 4 cos squared theta. Then we have plus 2 cos theta. Then the 1, when we move it to the other side, it becomes minus 1 equals 0. Then we let u equal cos theta. So we have 4u squared plus 2u minus 1 is 0. So we can use our calculator to kind of factorize it for us. So we've got 4, 2, minus 1. Okay, so we got 1 plus root 5 over 4 and 1 minus root 5 over 4. Now for a situation like this, what you would do in the exam is you'd pretend like you use the quadratic formula, yeah? So you'd say u is minus 2 plus or minus 2 squared minus 4ac all over 2a, like that. But remember these values equal cosine, right? So we're going to say cos theta is minus 1 plus root 5 over 4, and cos theta is minus 1 minus root 5 over 4. So now we can work out our values. So remember what we said, for cosine, it's 360 minus. So we're doing inverse cos of, not done that right, minus 1 plus root 5 over 4, which is 72, interestingly enough. Now remember, for cosine, you do 360 minus, yeah? So you have 72, and then we're going to do 360 minus to get 288. And they are our two solutions on that side. Then we can go back and change that to a minus. We get 144. Then remember, you do 360 minus. So you get 144 and 216. And they are our two solutions for that one. Yeah? That's like one of the toughest year 12 questions, I would say, for trig they could ask. There's obviously a lot more that I usually put with my students in my full course, but this is a really tough question, even so. Yeah? Right, so here's a summary, which I told you guys. Now you might want to screenshot this. This is the overall, summary for trigonometry. When we solve trigonometric equations, we follow these rules in order. We use Pythagoras' identity to convert all terms into sine or cosine. We apply the inverse function of either sine, cos, or tan. We call this the primary value. For the secondary value, we apply these rules. For sine, 180 minus the primary value. Cosine, 360 minus the primary value. And for tan, 180 plus the primary value. Then we add or minus 360 to find all the other values in the range. Now remember, our PV may not be in the range, but that's okay, yeah? So I do recommend, why don't you screenshot this, yeah? Use it as reference whenever you're solving trigonometry, because the steps are always the same, yeah? And guys, if you learned something and you haven't already, I would appreciate if you hit the like button. Make sure you're subscribed, because next week I'm going to start differentiation. I'm going to start with differentiation from first principles. So if that's something that interests you, then for sure, make sure you're subscribed and you're ready for that one, because it's going to be a great lesson, yeah? I'm just going to quickly detail, at the beginning, I told you that I'm working with MES on developing the maths course. So I just wanted to give you a bit of details about what that looks like and how you can join if you're interested. So on my MES Maths course, I provide weekly lessons All those lessons are approximately 2 hours long, and it's for the year 13s at the moment, which is 2 hours per week. I mean, two 2 hour lessons per week. Every single lesson has professional workbooks that have been designed. So meaning, the lesson I've just done with you guys, all that lesson will be put into a nice document for you guys to print out and just follow along my lesson. So you always have my lessons ready, and then you can file it and all that good stuff. Just to hide me really quickly, is every single lesson has a homework just to get you exam ready. Like you've seen today, I always do exam questions. Now, every single homework has video solutions done by me. You can see from the image, that's me going through the question. So if you ever get a question wrong, that's fine. You can just watch my video and I explain exactly how to do the question. Yeah. There's my platform, the MES platform. On there, you'll have access to my lessons that, right now, it'll get saved. I'll download it, upload it so that you can rewatch it whenever you like. If you're revising in May, you can go back, watch any video you want for your revision. That's where you'll do your homeworks and get your feedback there and then. You also have unlimited access to mentors. These are a couple of our mentors right now. They're actually my old students, looking cool. And you can ask them, we use Discord for this. So yeah, if you're interested, this is everything that you get. But anyway, guys, thank you for joining me. Let me make myself small actually. If you're interested in my course, then hit me up on Instagram at Neil_B_algebra. Make sure that you tell me that you're coming from the stream. If you just DM me, just say stream in capitals or something like that, and I can provide you with more details and also give you some special discounts as well. Just because you're coming from my stream, you guys are hanging out, doing some maths. It's on your holidays, so you're enthusiastic. I love that. So if you are interested, follow me on Instagram, drop me a message, and I can give you more details about my course. And that's it. If you have any questions, I will hang about here. You can post them here as well if you want to hear it, live. But otherwise, if you want to know more details about pricing and all that stuff, then just hit me up on Instagram. And I post some funny stuff on Instagram as well. I do giveaways. Students post memes and stuff of me, and we create all that kind of fun stuff. So, if you want to join me on there, do so. But yeah, I'll hang about for a bit, guys. Thank you for joining me. And hopefully I'll see you in my differentiation stream next week. Have a nice rest of your holiday, guys. I'll be hanging about though. So if you leave, feel free to say bye. But otherwise, I'll hang about for a few minutes if you do have any questions. Even if you have a question about today's stream, you can ask me there. Thanks, Boomy. Thanks for joining me. See you. Thanks, Apasna. Thanks for your engagement today. See you. Alright, guys, I'm going to check out. I'll see you next week. Bye.